Hey guys, Dr. Brown here, and this video tonight is about why do we study math? Okay, well, at the end of the day, it's all about modeling real life situations. So we have a real life situation here. Let's assume for a moment we are working in the coroner's office, I guess, where they find a dead body. Okay. They discover a dead body in a 70 degrees Fahrenheit closed room. So the room temperature is 70 degrees all the time. They don't know how long this person has been dead, but they perform a core temperature on the body and find out that it's 85 degrees Fahrenheit. 1 hour later, they measure that temperature again and it's 80 degrees Fahrenheit. So our question, let's assume you're working here and your boss says, hey, how long has this person been deceased? How long ago did they die? Because you're trying to put together the crime scene and all the items. So they need to know that. So T0 is the time at which the person died. We're going to make the assumption they had no fever. And so 98.6 degrees Fahrenheit would be a normal body temperature. The room is 70 degrees. T1 is when they found the body. The core temperature was 85 degrees. The room is still 70. We're calling that T1. Then an hour later, so T1 plus 1, is the core temperature or body temperature is 80 degrees, the room is still 70 degrees. So we're trying to find the amount of time that elapsed between when they passed away and when the body was found. This is why you study math. Okay, all right, and physics and other sciences. All right, there is I may be off the screen for just a little bit here. The Newton law of cooling. He says that the rate of change of the temperature, in this case of the body, but it could be of this eraser if it's in a hot room, okay? The rate of change of that temperature of the body with respect to time is proportional to the difference in temperature between the body and the room. So the temperature minus, and actually he said the temperature of the device you want to know, or in this case the body, minus the temperature of the medium that it's in, so whatever that ambient is. So we're going to substitute a few words or a few symbols here. T sub B is the temperature of the body. The medium temperature is the temperature of the room, T sub R. Okay, so the rate of change of the temperature of that body with respect to time is proportional to the difference in the body temperature and the room temperature. So now there's another, and I'm going to kind of box these in because we're walking through the different tools that we're going to use to solve this. Now the next thing we're going to do is separation of variables. If I can spell, separation of variables. We're going to divide both sides by T sub B minus TR. Okay, so if I divide it here, it becomes 1. So the rate of change of the temperature of the body divided by the temperature of the body minus the temperature of the room. And I'm also going to multiply both sides by dt, the differential of time. So this equals k dt. So now we have like terms. So that's separation of variables. Now then, what should we do now? Well, I need to integrate these. So I have an integration just int integration, but I'm going to use u sub. All right, so let's let u equal T sub b minus T, the temperature of the body minus temperature of the room. Du then, and keep in mind we're differentiating here with respect to T sub b, the temperature of the body. So that just becomes the derivative of T sub b. Temperature of the room is a constant. What's the derivative of a constant? 0. So what do I have here? I have the integral of du, which is the derivative of T sub b, du divided by the difference in the body and room temperature, and that's u. Integral of du over u, and that equals the integral of k dt. So this is a natural log of u. Derivative of a function over the function is the natural log of u. And what is u? T sub b, temperature of the body minus temperature of the room. And that equals kt plus natural log of C1. Now, I could have just said C1. Since I have a natural log here, I'll do the same there. It's still just a number. All right, so we used u sub. Now we need to look at logs. It's the next tool we're using. And you may be thinking, oh wow, I had algebra, I learned logs, I learned exponential rules, I learned various items, but I never got into what do I do with those in terms of a real world situation. All right, so logs, we're going to take in exponentials. I'm going to multiply both sides by e. Now e cancels a natural log, so I end up with T sub e minus TR. I've got to do the same here. So I end up with C2 e to the KT. Oh, it's looking better all along. Now, you may be thinking, wait a minute, I know T sub b, TR, I don't know C2, I don't know K. We have some conditions here. The initial condition would be at t equals 0. T is 0. Time is 0. If I put a 0 here, I end up with e to the 0. What is any number raised to the 0? It's 1. I have 1 times C2. Well, that's C2. Wow, this is awesome. So T sub b, the temperature of the body minus the temperature of the room equals C2 when at time equals 0. So what is T sub b? 98.6 minus 70, and that equals C2 e to the 0, and that's 1, right? So I have 28.6 equals C2. That's awesome right there. Now, what was the tool we just used? Initial conditions. Wow, we use Newton's law of cooling, separation of variables, integration using u sub, logs and exponentials, initial conditions. Now then, okay, let's get rid of this, get us a spot to work. Let's take our equation up here. We have temperature of the body minus the temperature of the room equals C2 e to the KT. Now we just solved for C2, that's 28.6. Okay, we have 2 more conditions here. Let's take and look at T1. I'm going to go ahead and write C2 up here, 28.6 e to the K. My writing is terrible today. K T1, and that equals 85 minus 70. The body temperature at T1 was 85. The room temperature is 70. 85 minus 70 is 15. Okay, let's do the same thing here at t1 plus 1. I have 80 minus 70 is 10, and that equals C2 times e to the k t1 plus 1. You could say t2, but you'll just eventually have to change that to t1 plus 1. All right. Now let's divide 28.6. I have 15. I have two equations here now. I only have one variable I'm trying to figure out, but I have two different times. So I have 15 divided by 28.6, and that equals e to the kt1. Now I have 10 divided by 28.6, and that equals, I'm going to distribute this k. That's k times t1 and k times 1. So I have e to the kt1 plus k. Okay, all I've done is distribute that. Now then, I want to get rid of this e. So if I take the natural log, it wipes that out. Natural log of this one wipes that out. Now then, I have natural log of 15 over 28.6 equals kt1. The natural log of 10 over 28.6 equals kt1 plus k. Remember, we're trying to solve for k. I have two equations. If I were to multiply this equation by a -1, I would have a negative here, a negative there. This plus would become a negative. Now, if I were to add those two equations together, this one's positive kt1 minus kt1. Those cancel each other. So you'll notice I have, if I were to perform this, natural log of 15 over 28.6 minus natural log of 10 over 28.6. Here comes another rule, okay? If I don't trip over my cord. If I have, I'm going to call this A in this parentheses here. If I have the natural log of A, and I'm going to let this one be B, minus the natural log of B, that's the same as saying the natural log of A divided by B. Now, so we've got another rule here, logs. Okay, so that's the rule here. So what can I do with this? I can say the natural log of 15 divided by 28.6 divided by 10 over 28.6 equals, these two cancel, minus k. Invert and multiply. If I do that, for the sake of space here, I end up with 28.6 over 10, and that equals minus k. 28.6 cancel, 15 divided by 10 is 1.5. So all this becomes a natural log of 1.5 equals minus k. Okay, so 0.4055 equals minus k. If I multiply both sides by -1, this becomes a negative, that becomes a positive. So we've just solved for k. K is 0.4055. Okay, so we've got logs, we've got exponentials. We had a complex fraction in here, right? Or a compound fraction. So you learned about that in algebra. Wow. Okay, so what do we have? Now we have our equation. T's temperature of the body minus the temperature of the room equals 28xc2 e to the kt. But since we want to know the time that's elapsed here from 0 to T1, we just need to figure out what T1 is. So if we were to solve that for T1, we'll divide both sides by C2. That takes care of that one. I'm going to do a natural log here. That takes care of that. Then I'm going to divide both sides by K, and that equals T1. And what was all of that? That was just some algebra. Actually, algebra is all throughout this, just adding, subtracting, multiplying, dividing algebraically, or general math. Okay. All right, so let's figure out with T1, we had 85. Temperature of the body is 85. Temperature of the room is 70. So 85 minus 70 is 15. So I have the natural log of 15 over C2, which is 28.6. So the natural log of that divided by K, which was a negative 0.4055, and that equals 1.59 hours. So that person had been deceased 1.59 hours. This is what, or things like this, is what you're going to do as an engineer or a scientist at wherever you're working, or a technical person involved. You're going to read about a problem. It's not going to be, here's the equation of machine A, now solve that. That is not the way it's going to be. Practice as many word problems as you can, because that's what the world's going to be like. Get to where you can read one, extract things out into a table, understand some very physics that goes along with that. Because in this case, we had the Newton law of cooling, we did separation of variables, which was a differential equation technique for a very simple equation. We did integration using the U substitution. We did perform various log and exponential functions. We utilized initial conditions that we had pulled out of the problem. Again, we had various logs. We had a compound fraction. We had various algebraic methodologies that we're working with formula manipulation, solving for the variable that was of concern. Some of this you learned in the 7th, 8th grade. Some of this you learned in high school. Some of this you learned in 1st and 2nd year college. But all of it came together in that problem. Why are we doing this? Together we're trying to build a better tomorrow, and do that through math. Keep studying, guys. And that's all for now, and we'll talk to you again next time. Thanks.